We're discussing acid and base now, or some other chapters.
Yes.
Acid and base, and the last topic that we have written in the previous class. Tell me, is there anyone in the class who can tell me? Jaslyn, you in the previous class of chemistry?
No, sir.
You didn't attend the previous class. Ammar, you attend? Hashit, you attend the class. You are attending every class. Yes, Hashit, tell me that what was the previous topic of the class?
Sir, acid and base.
Acid and base is is a chapter name. The topic that or read any line that way. Okay, let me explain. Did I taught you the acid base indicators? Acid base indicators why glucose is able to don't show any effect on litmus paper. Does we have done this one or not?
So 1 minute, I'm checking the copy.
Jacket.
Yes, sir, we have done.
We have been what?
We have done. Yes, sir.
So I think it means that nobody is maintaining their notes because you can't read even what I am writing, what I am teaching you. So how it is possible that nobody is going to learn each and everything? Okay, so tell me the last topic that we have written in your copy. We started in the previous class. Read 2 or 3 lines from the last topic. Does we done the olfactory indicators? Does we done the indicators? Ashit, you tell me you attended every class?
Yes, sir.
We done indicators?
Sir, olfactory not done.
Olfactory indicators. Okay. Okay. Let us start with the another topic, that is strong acid and strong base. What are strong acids? Strong acid.
When was your class? When was your class last time?
It was on the previous Thursday. Sorry, previous Tuesday. What is the date? Today is Tuesday, na? Tuesday. Okay. So
Yes,
let's discuss the strong acid and strong base. What are the strong acid and what are strong base? So let me discuss this one. So you know that when acids are added to water, they produce H plus ions. They produce H plus ions. Those acids which completely dissociate their H plus ions in aqueous are called strong acids. Let me explain you. For example, if you are having an HCl, hydrochloric acid, okay, and you are having a 10 molecule of HCl. So when you add it, everyone is going to dissociate H positive and Cl minus ion. They will dissociate into H positive and Cl minus ion. You understood? H positive and Cl minus ion. You understood?
yes, sir. Yes.
So acids are added to water, they produce H plus ions. So those acids which are completely dissociating, they are called a strong acid. For examples, for example, If I'm going, for example, HCl, hydrochloric acid. Turn on your camera. Let me check whether you are writing or not properly. Everybody turn on your camera. Let me check whether you are writing or you are just coming into the class and you are not writing each and everything. Ridwan, Madiha, Jaslin, I'm just going to turn on your focus mode so that nobody can see you. Only I can see you. Okay. Jaslin, Madiha, Ammar, Hashit, what I'm saying, turn on your camera.
So get stuck on my camera.
Okay, let it be. But other students?
Sir, can you see me?
Yes, I can see you. Okay. If I'm saying this SCA like H2SO4, like H2SO4,
Wait,
that
can you repeat it again?
HNO3. Okay, these are the examples of strong
Yes,
acids.
sir.
Yes, yes. What are you saying?
Yeah. Can you repeat what you said before?
Yeah, I said that they are the strong acids and strong base. Okay, so if the acids are added, those acids will be added to water, and they are completely dissociating the RH plus ions. I mean, every molecule is going to dissociate it into H positive and Cl minus ion. So we will consider it as a strong acid. For example, if you add HNO3 to water, when you add HNO3 to water, then it will gives you H positive and NO3 minus ion. NO3 minus ion. NO3 minus ion. H positive and NO3 minus ion. H positive, NO3 minus ion. H positive, NO3 means every molecule is going to dissociate into H positive and NO3 minus ion. You understood?
Yes.
Yes, sir.
But what are weak acids? For example, if you are having a weak acid, like example, you are going to have CH3COH. So if you are having a 10 molecule of CH3COH, so all of them are just going to have in their original form, only one or two are going to dissociate into H positive and CH3CO minus ion. Okay. Otherwise, they generally remain into its original form. They don't dissociate. Some of them are going to dissociate. Okay. So like this one and this one is going to dissociate, and the other are remaining. They are not dissociating. So if we have a strong acid, they all are going to dissociate. If we have the weak acid, then they are not going to dissociate. You understood? Understood?
Yes, sir.
Jaslyn, understood?
Yes, sir.
Okay, so write down the definitions of, have you noted the definition of strong acids?
No, sir.
Note it down. Everyone should make a proper copy. Dear students, if you want to achieve very good marks in the subjects and you want to have the better knowledge of your subjects, and it is must that you must make the proper notes for every topic that we are studying so that it will help you to gain better marks in your examinations. Okay. Done. Should I move to the next topic?
Yes, sir.
Okay. Jaslyn, done.
Yes, sir.
Ashit. Okay, that's okay. So next is weak acids. Weak acids are simply, if I'm saying that when you add it, they are partially dissociating. They are not 100% dissociating. Okay. So if I'm saying that those acids that partially dissociate here H plus ions in aqueous. Aqueous means water. When we add it to water, this is considered to be as aqueous. So those acids with that partially dissociate the H plus ions in aqueous are called weak acids. Examples like we have H2CO3, that is carbonic acid. Carbonic acid, that is H3PO4, phosphorus acid, H3PO3, no, this is not phosphorus, this is phosphoric, this is phosphorus acid. Okay, CH3COH, that is acetic acid or ethanoic acid. Ethanoic acid. Carbonic acid, phosphoric acid. Okay, phosphorus acid. So these are important. Note it down. Jaslin, are you saying something? You are muted.
No, sir.
This Madiha has turned his camera on, but actually I'm seeing a mark of uh, some mm, some software over it. Okay. Done. Should I move to the next topic?
Yes, sir.
Yes, sir.
Okay. Now moving to the next topic is that is weak base. Similarly, weak base. First, strong base. Strong base. I'm just writing only in the simpler form, not writing the whole definition. Dissociate OH negative ions completely in aqueous. For example, NaOH, KOH. Similarly, weak base, partially dissociate OH negative ions in aqueous. Aqueous. Examples: ammonium hydroxide, ammonium hydroxide, calcium hydroxide, oxide, magnesium hydroxide, MgOH whole twice. Okay. Done? Written?
Yes, sir.
No,
Should I
sir.
move? No, note it down. That is magnesium hydroxide, ammonium
One
hydroxide,
second.
calcium hydroxide. Okay. So these are the weak bases. Okay. So we are just going to have a very important role of this one. So let's move further. Now moving to the chemical properties of acids. What are the chemical properties of acids? First of all, acids when react, with metals, they will give you salt plus hydrogen gas. You understand? What they will give you? Salt plus hydrogen gas. That you have studied in the metals and non-metal chapter also. Okay. So if I'm saying what are acids, so there are some terms and conditions. Acid must be above hydrogen in the reactivity. Sorry, acid not metals. Metals must be above hydrogen. Okay. So metals must be above hydrogen in the reactivity series. Metals must be above hydrogen. What is it? Metals. Okay. So for example, if I'm saying that Zn when react with HCl, what it will gives you? What's the product? What is the salt form? Zn when react with Jaslin, with one. You are muted, Jaslin, you are muted.
Zn, ZnCl plus H2O.
No. That you know that this is HCl. So Jaslin, you are saying something, but your mic is muted. Your mic is muted, Jaslin. This is
Zn2HCl.
then 2HCl. H, here you see that if you are having any problem writing these salts, so what you need to do here is write the name of acid first. Okay, write acid first. For example, this is HCl. Write the name of acid first, and then the metals. Okay, and this, the hydrogen from the acid is being removed. Okay, because it is going to produce the hydrogen gas here. Okay. Now, what is the formula for when zinc and chloride are going to make the compound? So zinc and chlorine are going to make the compound. What is the formula for this one?
ZnCl2.
Yes, it will be ZnCl2.
Cl2.
Okay. So this is 2 and this is 1. 1. So when we multiply this one, you will get ZnCl2. Okay. So this will be ZnCl2. Got it? You understood?
Yes, sir.
Okay. So ZnCl2 will be the salts. For example, if I'm having H2SO4, when it react with Na, what would be the formation? What will be the name the salt? What it form?
Na2SO4.
Na2S.
Na2SO4.
Na2SO4. Yes, because we are just going to remove the hydrogen from here. Now just think that what salt will be formed when sodium and sulfur are going to make the compound. Okay. Got it? Sure.
Yes.
Okay. So similarly, but you know that sodium is going to have one valency and SO4 is going to have two valency. So you have to multiply this one, and this will be Na2SO4. Got it? This will be Na2SO4. Done?
Yes, sir.
Okay. So this is Na2SO4. So what will be the compound formed when HCl react with copper? Will it form copper chloride plus hydrogen gas? Will it form this one?
No, sir.
Hmm? Ridwan, your mic is muted.
No, sir. No.
Why?
Because copper is less reactive.
Yes, copper is less reactive. Since copper is less reactive, so it will not able to displace. So note it down that this will be considered to be as no reactions. No reactions. Why no reaction? Why no reaction? Because
Copper is
because
less reactive.
because we can write here that acid metals reaction, acid and metals is a displacement reaction, in which more reactive metal more reactive metal displace hydrogen ions from acid from hydrogen gas. Those metals, those metals that comes below hydrogen, comes below hydrogen in the reactivity series are not able to produce hydrogen gas with acid. Okay, so note it down. Acids and metals is a displacement reaction. More reactive metals displace hydrogen ions from acids and produce hydrogen gas. Means those, i.e., those are more reactive, means those are above hydrogen. Those metals that come below hydrogen in their reactivities are not able to produce hydrogen gas with acids. Okay, so there will be no reactions. Why? Because coppers come below the hydrogens. If you have the reactivity series like I'm writing here, so please note it down that I will write on next page.
Then, sir.
Is there anyone who is still writing?
Sir, I'm still.
Okay, note it down.
Done, sir.
Done. Okay. So we have this one, like we have hydrogen. Sorry, we have this potassium, the activity series, potassium, then sodium, calcium, magnesium, aluminium, zinc, iron, tin, then iron, that is tin, lead, lead, Pb is lead. Okay. Yeah. And then hydrogen, then copper, copper, and then mercury, silver, gold, platinum. This is copper, copper. This is silver. Sorry, mercury. This is silver. This is platinum. Sorry, this is gold. AU is gold. Gold. Okay, PT is platinum. So these metals don't react with acids. Don't react. Done.
Yes, sir.
So here is a case that if I'm going to have an example CH3COH, it is an acid. So when it reacts with sodium, what is the form? What is the compound form? This is acid. This is metal. So tell me. Tell me what product will form here. So let me explain you that when it dissociated, you know that this CH3COH, when it get dissociated, it forms CH3CO minus NH positive. Okay. So this one is the negative part, and this hydrogen is going to produce the hydrogen gas. Now it is sodium here. So both are going to react. They are both are going to form the formula. If I'm writing here CH3CO minus means it is going to have one valency and N is also going to have one valency. So accordingly, you write Na positive and CH3CO as negative as minus here, and they both can merge together. But this is a special case here that this formula is written like CH3CONa. And the positive is written at the end. In general, we write NaCl, like if I'm writing the salt Na positive and Cl minus. If I'm writing ZnCl2, this is Zn2 positive and Cl minus. So we write the minus on the right hand side and the plus signs at the left hand side. But if this is a case in which the CH3CONa, in which the negatively charged is written at the first and the Na is written at the last. If you write it like this way, it will be okay. But in the most of the cases, it is written like this way. Okay, so the product will be CH3COO Na plus hydrogen gas. Note it down. This is important. That is called sodium ethanoate. Sodium acetate. Aisha, why you left the class? Yes, Aisha. What's your name? Aisha. Your name is Aisha. Yes, Aisha. Your name is Aisha or some you are using
Yes, sir.
some other. So why you
Aisha,
left the
sir.
class?
Sir, I did not
Why
leave.
you didn't leave the class? Okay. So you attending the class right now. So this is
Sir, they told me
almost
to attend at 8:30.
at
8:30 UA time.
8:30 UAE time.
Yeah.
Oh. So let's stop. So right now here is 10. Okay, you are half an hour. Okay, we'll discuss to them. Okay. So let's discuss. Aisha, you are in 10th standard now?
Yes, sir.
Okay. So done, everybody. So Aisha, we are just right now we are just intermediate of this chapter. We will give you this is your first class of chemistry now, or are you attending this class of previously?
No, sir, this is my first class.
This is your first class. Okay. So we'll give you some extra time that what is happening in the class. Okay. After the class is over. Okay. So
Okay,
the
sir.
other students are going to leave, but I will teach you because this class is starting at 9:30 according to the Indian timings. So from the 8 it is being started. So you are half an hour left late. Okay. So we will discuss this one. Okay. So what we are studying right now, we are just studying the acid bases and salts, and we are just studying the chemical properties of acids. Okay. Chemical properties of acids.
Okay, sir.
So uh, so now, because if this is chemistry and this chemistry is the only subject that you will understood it from the beginnings. Okay, so if anything you are not getting in the class, so don't worry, we will teach you again. Okay, so done, dear students, done. This is sodium
Yes,
acetate
sir.
and hydrogen gas is produced. Okay, now moving to the next part, it is very important that you know that acids when react with metals, they form salt plus hydrogen gas. Okay, but I have told you the exceptions of metals, that metal should be more reactive than metal should be more reactive than hydrogen. Okay, now if I'm saying that there is a terms and condition for the acids also, that acid must not be HNO3. If it is HNO3, if it is HNO3, then the metal must be either magnesium or manganese. It should be either magnesium Mg or manganese Mn. You understood? So what I'm going to explain you here, that you know that H2SO4 when react with metals, for example, if you have H2SO4, it react with sodium Na, so it will give you sodium sulfate Na2SO4 plus hydrogen gas. Tell me, Ashit. But what happens if in case of HNO, this one, if we have taken HNO3, so HNO3 when taken with react with sodium, it will not form the hydrogen gas. It will form sodium nitrate NaNO3, NaNO3 plus water plus some of the nitrogen oxide, NO2 or N2O5. Okay, so it is not going to produce the hydrogen gas. Why? If it is HNO3, if we have the metals here, it is also more reactive than hydrogen. This is the second highest in the reactivity in the series. So still it is not able to produce the hydrogen gas. It is producing the water. Why? So this is an important case because HNO3 is a strong oxidizing. This acid, HNO3 means nitric acid. Nitric acid is a strong oxidizing agent, is a strong oxidizing agent. So what is going to happen that it oxidizes the hydrogen ions to water. That the hydrogen gas that is going to produce, it oxidizes it and form water. Okay. So if I'm saying here that, let me help you. Okay. So what is going to happen here is that HNO3, that is the nitric acid on reaction with metals does not produce hydrogen gas. Why? The answer is that HNO3 being a strong oxidizing agent, oxidize the H plus ions to water and itself get reduced to any nitrogen oxides. Any nitrogen oxide. Okay. So HNO3 being a strong oxidizing agent, oxidize the H plus ions. Oxidize the H plus ions of acids. Of acid to form water. H plus ions of acid to form water and itself get reduced to any nitrogen oxides such as NO2, N2O5, etc. Okay. So what does HNO3 does? Actually, HNO3 is a strong oxidizing agent. So let's suppose this is a beaker. Okay, when you add, this is containing the HNO3 and you add some zinc metal to it, Zn. So when you add zinc metal, so the H plus ions of acids are oxidized to water to form water because HNO3 is a strong oxidizing agent. Okay, so it oxidizes the H plus ions, okay, to form water and itself get reduced to nitrogen oxides. Got it? So HNO3 does not produce hydrogen gas on reaction with metals. Understood? Everybody? So let me explain you. But however, there are two metals. However, there are two metals, that is magnesium and manganese, which when react with HNO3 nitric acid can produce hydrogen gas. For example, if I'm having HNO3, when react with zinc, it will form, magnesium. So what salt will be formed? Tell me. Name the salt form. Magnesium nitrate will be formed. Just remove this hydrogen from here because it is going to produce the hydrogen gas. Now you are having the nitrate ion, NO3, and magnesium ion. Okay. Magnesium ion and nitrate ion. Okay. So if this is magnesium is going to have two valency, nitrate ion is going to have one valency. So what should be the formula? Jocelyn, tell me. What should be the formula of magnesium nitrate? Magnesium is going to have 2 valency and nitrate ion NO3 is going to have 1 valency. So what is the formula of magnesium nitrate? You are muted. You are muted. Unmute yourself first. Now tell me. Tell me. What is the formula of magnesium nitrate? Mg NO3 whole twice. Got it? This is magnesium nitrate. So magnesium nitrate when react with HNO3, it will produce hydrogen gas. So this is a special case. Okay. So let me tell you that how was the type of question that is being asked in the examinations regarding to this one. So the type of question that usually being asked in this portion. This type of question generally asked. This question number 40, not 40. Generally metals, you see that generally metals when metals are treated, you see that generally when metals are treated with mineral acids, hydrogen gas is liberated out. You see that hydrogen gas is liberated out. But when metals except magnesium and manganese are treated with HNO3, the hydrogen gas is not liberated out. Why? So that we have done this question. So please note this question also. This is from the NCERT example. That is an important question. Note it down. I will send you all the questions. Okay, I will send it to you. Please note it down. Question number 40. Done. Jocelyn, done.
And so,
Okay. So now let's move further. that is the next topic. That is the next property of acid. That is acids when react with base, they form salt plus hydrogen gas. Okay. Salt plus water, sorry. So that is also called neutralization reaction. That is also called neutralization reactions. Neutralization reaction. So please complete some reaction that I'm going to give you. That HCl when react with NaOH, what it will gives you. If H2SO4 react with ammonium hydroxide, what it will gives you. If calcium, if H2CO3 carbonic acid and react with calcium hydroxide, what it will gives you. I'm writing H3PO4 when react with calcium hydroxide, what it will gives you. Note it down, complete the reactions, please. So here you will see that this is H2. So this is NaCl, Na, and Cl. You know that OH and H is going to make water. So H and OH is going to make water, and these two are going to make NaCl. Okay, because
NaCl2.
no Cl2. Both are
sorry,
going to have the
NaCl.
same valency.
Yes, yes.
That both are going to have the same valency. Similarly, this OH and H is going to form water. This now tell me the formula of ammonium sulfate. This NH H2SO4 when react with ammonium sulfate. So what formula is going to give it? Tell me.
So, so NH3SO4.
Sorry, this is the NaOH. Okay. So the formula for this one will be, you know that this and this is going to form water. So this will be water. And this ammonium hydroxide, NH4 and SO4. SO4. So SO4 minus 2 and NH4 1 positive. So this is going to have one valency. It is going to have two valency. Got it? This you have
Yes.
to learn. This you have to memorize in the valency chart I have given you in the first class. So you have to memorize that chart, okay, properly, dear student. This is very much important that you must know how to write the correct formula of the compound. This is the NH4 whole twice. Why whole twice? Because this is not a one atom, it's a group of atoms. So we are just going to keep it in the bracket. So NH4 whole twice SO4. Okay, you understood? This will be NH4 whole twice SO4 plus water. Now tell me this one. Tell me this one.
So CaCO3.
CaCO3.
CaHCO3.
Very good. CaCO3 plus water. Okay, now this one. H3PO4 plus calcium hydroxide.
So CaPO4.
A3PO4. We have Ca3PO4. Okay, why? Because Ca is going to have valency 2. No, this is not Ca3PO4. Because calcium is going to have 2 valency and PO4 is going to have 3 valency. So they will cross multiply. We'll get Ca3PO4 whole twice. Okay. Got it? Jaslyn, you understood? So this valency chart is very important that you must remember to write the formula, correct formula of the compound. Okay. This will be Ca3PO4 whole twice plus water. Okay. Now moving to this question, let's move further. Done this one? Now moving to the next topic is the similar topic, that is, you know that acids when react with base, it just gives you salt plus water. Salt plus water. But you know that I have taught you in the first session, in the first part of this chapter for this class, that there are some strong acid, weak acid, strong base, weak base. Okay. That we were discussing in the previous classes. So if I'm saying this is acid, so if I'm saying that strong acid when react with strong base, it will gives you neutral salt. Neutral salt. Neutral salt plus water. Similarly, weak acids when react with weak base,
Neutral
it
salt.
will also give you neutral salt. But what would happen when a strong acid react with weak base? It will gives you acidic salt. Acidic salt. And this salt will be acidic in taste, means sour in taste. Okay. Plus water. Similarly, if we are going to have this this weak acid react with strong base, it will gives you basic salt.
Basic salt.
Basic salt. Okay. Done. Please note it down. Have you noted this one, the previous slide? Have you noted this one?
Yes, sir.
Note this one.
Sir, at last you wrote base plus salt, basic plus salt.
This will be basic salt. Plus
And
water.
it's plus
and water.
H2O.
Yes, it will be water. A silly mistake.
Then sir.
Done. Okay. Now tell me, if you are having this NaOH when react with HCl, you form NaCl plus water. So what is the is it the acidic salt, basic salt, or the neutral salt?
Neutral salt.
This will be neutral salt because this is a strong base, strong acids, both are strong. So it will be neutral salt. Okay. Just if I'm going to give you the examples of this one that we have written previously, this is neutral salt. Neutral salt. Tell me this one. Will it be acidic or basic salts? Or neutral? This one. Ammonium sulfate.
So basic.
Basic. Jocelyn, you tell me. Is it acidic or basic salt?
No, sir, it's
Mute.
acidic, I guess.
First, you unmute yourself. Just tell me. You are still muted. Tell me. Yes. It will be acidic or basic. You know that H2SO4. Check where we have written this one. That in the first part of this chapter, when we are discussing in the first part of this class, I have taught you the strong acid, strong base. Okay, you can read. So if I'm writing here, this H2SO4. Okay. So this is H2SO4 and this is strong acid, and this is weak base. Okay, so strong acid and weak base when react together, they form basic salts. Sorry, acidic salt. This is acidic salt. Okay, you understood?
Yes, sir.
Yes, sir.
Similarly, this H2CO3. Similarly, this H2CO3 and react with this. This you need to keep in mind here that this is very important for you, that you need to understood that I have written this calcium hydroxide in weak base, as a weak base, but it start behaving as a strong acid, strong base in when it is treated with weak acid. For example, this H3PO4 is weak acid. So it will start, this is H3PO4. So when it react with calcium hydroxide, it will gives you calcium sulfate Ca3PO4 whole twice plus water. But this time, this will be considered as basic salt. Why not neutral? Because it is weak. It is also weak, I have taught you. But here, this is not so much weak as comparison to this weak acid. So this is behaving as a strong base here, strong base in comparison to this one. For example, if I'm having carbonic acid, H2CO3 plus Ca, H2CO3, this is carbonic acid plus calcium hydroxide. This is weak acid. So this will give you calcium carbonate, CaCO3 plus water, and it will gives you what? Now it is behaving as a strong base. Okay. So this is basic salt. But when this calcium hydroxide is treated with strong acid, this calcium hydroxide, let's suppose if I'm just treating it with H2SO4, strong acid. Now it is start behaving as weak base, and this is strong acid. So in case of a strong acid, this behave as this is not so much strong as comparison to this strong acid. So this will behave as a weak base, and then it will gives you calcium sulfate, CSO4 plus water. So this is a basic salt. Sorry, acidic salt. Similarly, CaCl2, CaOH whole twice, when it react with HCl, it will gives you CaCl2 plus water. And this will be what? This will be acting as weak base here, strong acid. Okay, so we can say that this, note it down first, each and everything. Done?
Then sir.
So note a statement here that calcium hydroxide behave as weak base when react with strong acid, with strong acids, and give acidic salt. Acidic salt. And similarly, and it behave as weak, sorry, strong acid, strong base when react with behave as strong base when react with weak acids. And thus give basic salt. Example. See example. Calcium carbonate, comma, calcium phosphate, Ca3PO4 whole twice are basic salts. Basic salt. And the CaCl2, calcium sulfate, these are acidic salt. Acidic. Okay. Got it? Understood,
sir.
everybody? So if I give you in homework that if I give you some questions regarding to this one, that if you are having this ammonium chloride. So if I asked you the parent acid of this ammonium and chloride, so can you write its ammonium hydroxide is parent base and HCl is parent acid? Okay. For example, if I'm having calcium carbonate, what is the parent acid and parent base of this one? That is calcium hydroxide is the parent base and H2CO3 is H2CO3. CO3 comes in H2CO3 in acids. Okay, so this is the parent acid. For example, if I ask you calcium sulfate, so what is the parent acid and parent base? This is calcium hydroxide and sulfate ions come from H2SO4. Okay, so this is parent acid, and this one is parent base of this salt. You understood? So this time examination question being asked that what are the parent acid and parent base of a particular salt. So we'll give you the homework. Okay, so that's all for today. We'll meet you in the
Yeah.
next one.
Sir, should we by heart this all?
Should we
By heart this all.
by heart?
This all. I mean the parent acid and parent base.
Yeah, you can solve it by it, but because you can you can solve it, but you have to write the answer. Okay, let me show you that what type of questions comes in the examinations. Let me show you. Wait a minute. This type of question generally comes that this formula is being written for the salt. Now the base is written. Now the acid being asked. Here the acid is given. The salt name is given. That copper sulfate is here. The formula